Hi guys, my name is Ivo and welcome to the video. In my current video series, we're talking about solid principles and clean code in a huge code base. Usually when people teach about these principles and these practices, they show smaller code bases, they show demo code, they show very tiny examples, and that's completely fine. There is nothing wrong with that. But it's suitable only for beginners. And this is why some of the people and some of the students don't quite understand where to apply the solid principles and where to apply the clean code and such. So this is why I decided to create this video series and these lessons to show you a huge code base with a real-world application which is used in a production environment by thousands of people. So we're searching for solid violations. In the current video, we're going to talk about the open close principle. If you haven't watched the previous ones, or if you haven't watched the introductory in which I explain what the system is all about, make sure you do. And also, it's a good idea to subscribe to my channel and turn on the bell notifications because I publish advanced C# lessons. And you don't want to miss them. Good, now let's start. I've prepared a couple of examples to show you how exactly the open close principles are violated here in this particular system. The open close principle in a nutshell says that a class should be open for extension but closed for modification, a method too. So the whole idea here is how to extend a class without actually open it and change it. Good, let's start with the first example. The first example is here in the OGS data class, which tries to use reflection to store the repositories. So if we remove that like this is a very open-close method, a very good open-close method, because we can easily get any type of repository, because it will check this dictionary and it will create it by using reflection, by create instance, by the activator create instance. The problem here is the whole open close here is that if I create a new model, for example, if I don't have a class cat, and if I create a class cat in the system, then all of a sudden this method will work, because we can get a repository by just providing the cat. So this method works with the new functionality and the new model without having to implement something inside. Also, if I then add another model, for example dog, then this method will continue to work. So if the method looked like that, it will be perfectly compliant with the open close principle. However, the method looks like this. The method is doing type checking. Every time you do type checking, like here, check whether the type of T is a submission, check whether the type of T is a user profile. This is essentially a violation of the open close principle. Every time you do type checking somewhere, you can improve it, period. So this particular case here is no longer open for extension without modification. Consider if I have cats repository. Then I need to go and say if type of T is assignable from type of cat, and I need to change the logic. So I need to add some code to make it work with the cat's repository. And this is because there are repositories which are specific, they are not generic. So for every specific repository, like the submissions repository here, the user repository here, and so on, we will have to add some code here, and that's not very convenient, and that's essentially a violation of the open close principle. A better approach is to mark this classes with a specific interface. For example, specific repository. Something like that. Specific repository. Adding this interface will allow you to find all classes which implement specific repositories and add them here and create them here. This will be easier because you may say something like if type of t is assignable from type of specific repository, then get the class which is implemented here and provide it here. So we can add logic which will allow us to create a new specific repository, mark it with interface, and this method will continue working without the need to change it. This is how we may introduce OpenClose here, because currently it's violated because of the if else and the type checking. That's not okay. Okay, let's get to the next example. The next example is a good example of the open-close principle. Because in the system we have the so-called checkers. A checker validates the output of the user by a certain algorithm. So the output of the user's code may be a string and we validate the string against a test. But we have different checkers in the system. For example, we may have case-insensitive checker. This is where we don't want to validate the different cases. We may have exact checker, which means check line by line. They should be exactly the same. We may have precision checker, and the precision checker is validate whether the response, the result, the number equals a number with some sort of a precision. So this will be valid with the precision checker. We may have sort checker, which means sort the output first and then check it, and so on and so on. We may have trim checker to trim extra unnecessary lines in the output of the user. So we may have different types of checkers. Each one of them will have different algorithm. In the future, we may add more checkers. So how to create a checker system without having to change the checker every time a new checker is introduced? How to make it open-close? To make it open-close, here is a good way to use open-close. We create an abstract base class for every checker and we mark it. Then each different checker is just a new class. For example, precision checker, new class. Trim checker, new class. Sort checker, new class. This way, if we want to add a new checker, my cool new checker, I just add my cool new checker like a class, and it will still work as long as it implements the base checker abstract class. So this is a good example of open-close principle, because the checker class itself is used here in some tests input model, which just says checker create checker, give me this, give me that, and that's it. So every time I want to create a checker, I can do it automatically. I just add a class and this checker is now recognized in the system. I don't need to change anything which is already written. And this create checker is also using open-close because it loads the checker super easily by using reflection. We don't need to change the class when we add a new checker, and this is essentially OpenClose. The same thing is done with the compiler class. The compiler class, because the system recognizes different kinds of languages, we have a C++ compiler, a C++ zip compiler, C# compiler, .NET compiler, Java compiler, MS Build compiler, different kinds of compilers. And it's using the same strategy. If we want to add a new compiler in the future, it's a good idea to have a way to create one without changing anything in particular. However, we have a small problem here, and I'm going to show it in a minute. But the system is essentially the same as the checkers. Each compiler is inheriting an abstract class, and C# compiler implements its specifics. Java compiler implements the Java specific, and so on. So this is essentially OpenClose for now, because when I want to add a new compiler, I just add a new class, my cool new compiler, I implement and inherit from the base compiler class, and everything is fine. It's OpenClose. So it's the same example, but there's a little bit of a problem here, and the problem is the switch statement. When you see a switch statement like this means that we are violating the OpenClose principle, because here we receive a compiler type, and based on that type, we create the compiler like this. So essentially this means that if I add a new compiler, I need to come to the compiler class and add the new case compiler type, my new code compiler. And I also need to change this enumeration here. So every new compiler forces me to change these two classes. Even though in terms of OpenClose it started great, this is a bad example because I still need to change some classes. The way we can do this is again with reflection. First, these settings here should be behind, shouldn't be static at all. These settings should be behind an interface. I'm going to talk about this in the when we hit dependency injection, the D from the solid. But these shouldn't be static. So if these are not static, we can easily inject them. And these compilers may receive the settings as an interface here and extract whatever they like. Because currently the responsibility of the concrete settings is in this base class, and it shouldn't be. If your base class knows about the inherited classes, if your base class knows about the child classes, like here we have a compiler class and it knows about its children, this is inherently wrong. This is wrong, and this is not OpenClose at all. So how to fix that? First, the settings need to be an interface, and each compiler should know which settings to use. This is the compiler's job. It's not the base compiler's job. Each compiler should know its stuff. That's the whole encapsulation thing from the object-oriented design. Good. And then what we can do is we can easily use reflection to get all the compiler classes and, depending on the type, create them. I'm going to show that when we hit the clean code videos from this series. But for now, this is a violation because we need to go and change it. A reflection solution here will solve that problem, and it will be OpenClose compatible. But we need to first change the settings class. Good. Before we continue with the next example, I'm going to talk a bit about my mentorship program. My mentorship program is available on Patreon. The link is patreon.com/IvailoKenov, and this mentorship program aims to improve your software development skills. It gives you exclusive lessons, private communities, different polls, code challenges. The whole idea is to point you to the materials which you need to read, learn, and apprehend to become a better developer over time. And of course, with better developer skills, you have better salary, better jobs, and so on. You have career advancement. So this is my idea here, to provide you different knowledge which is needed in your career path. And I give a lot of different options. 52 people already joined the mentorship program and are enjoying it. So take a look at it. You may decide to join it too. For some of the example videos are, for example, the anatomy of ASP.NET Core request, the whole life cycle of the request response pipeline, how to work with Redis as a database, which are the use cases, some code challenges, some polls. Here we have a poll, a code challenge, trees and graphs, and all the different kinds of trees, and so on and so on. There are a lot of materials here. And every month I add more and more and more. So if you want to improve your skills, consider my mentorship program. Then, good, how to get the source code. While I'm in the browser, I'm going to show it. The source code is available in the whole system, the OpenJudge system. It's open source. It's available on bit.ly/your-source. So go to bit.ly/your-source and you will receive a repository. The repository actually contains all my source code which I use in this channel. So you have a lot of code to play with it, and the OpenJudge system is in the folder Huge Codebase. Go here and you will see the source code we're currently looking at. Back to Visual Studio. The next example is base code execution strategy. What is execution strategy? Well, different kinds of strategies in the system, different kind of submissions needs to be executed in different specific manners. For example, one of the strategies is to compile the code and validate it against tests. Another strategy, for example, the SQL strategy, needs to create a database first. Another strategy may create a database and execute queries. So we have different strategies in the system. For example, for the C# we have one strategy here. .NET Core compile, execute, and check execution strategy. For the Java we have multiple options. Zip file, compile, execute, and check, unit tests, Spring, Hibernate, project test, preprocess, and so on and so on. So we have a lot of different strategies. The blockchain strategy too. So we have a base execution strategy, which base code execution strategy, which the whole idea is if the user submission is code, we need to compile it, execute it, and validate the tests. Okay, so we have different kinds of results. We may have a success result type, memory limit, time limit, runtime, but if we want to add a new result type, we need to go here and check. So we have the same violation as in the previous codes, and this is the whole point of the OpenClose principle violations. If you have type checking, that's wrong. For example, like here, type check, runtime, type check, runtime, type check, memory limit, type check, success, and so on. These are essentially violations of the OpenClose principle. We can improve that by adding an interface and adding classes which implement the logic. And finally, we have submission processor helper, and this one creates execution strategies. And how it creates them? It creates them by checking again a type, a switch statement against a type. this is also a violation of the open-close principle every time, because if we add a new execution strategy, we need to add code here. And this is wrong in terms of open-close principle. And look at that, for each execution strategy we have a case, and that's quite long. This can be improved tremendously if we extract the settings to an interface file and inject the settings to the compilers. The compilers may be added to the dependency injection system. I'm going to cover that when we hit the dependency injection video. And additionally, we may use reflection to get the type and execute it. It will be way more easier, and we just need to add a new execution strategy and the class will work. Currently, if I add a new execution strategy, I need to go to the class and change it, which is essentially not okay. Good, this was everything for open-close principle. Every time you do a lot of if else, especially if it's type checking, you are violating the open-close principle. You can always improve it by extracting interfaces and using reflection, for example. So type checking and a lot of if else's or switches are bad in terms of open-close principle, as we saw. And a good example of the open-close principle, besides all the other code which don't have any open-close principle violation, is this checker class. This is a good example because automatically finds all the checkers. I just create a checker class and the system recognizes it. That's the beauty of it. For the other examples, every time I create something new, I need to add a new case. And you can see that in time, this class became huge. And that's apparently not clean code. It's not clean code, it's bad, it looks like code smell. If you're interested in code smells, by the way, I may create videos about code smells too. And I may show the code smells in this solution too. Good, very good. This is it for now. I'm going to mention my sponsors, and if you are looking for a new job, or if you are looking for your first job, consider my sponsors. The first sponsor I want to show you is Endeavor. Endeavor are constantly searching for passionate developers. They use a lot of latest tech, cloud platform. So if you want to advance your career, you may consider them as an option. The other sponsor I have is 2K, and 2K is a major company and they have great culture. When I negotiated the sponsorship with the manager in the current local office of 2K, I was impressed by their all about the employee attitude. They try to make everyone feel the best in their company. So 2K may be your future company. And finally, if you are living in Bulgaria, check out the fintech company Smart IT. They are also using the latest tech, and you may find it very interesting and very career advancing if you decide to see what Smart ID are doing. Again, they're only in the Bulgaria country. Okay guys, thank you very much. I hope you liked the video, and if you have any questions, hit the comment section below. In the next video we're going to cover the L part of the solid principles, and that's risk of substitution. Stay tuned. Bye for now.